Well, hello friends. Welcome back to the program. Today we are going to look at exceptions in our JIT compiler for JavaScript. And it's something that it's not necessarily the first thing I want to do today, but I've been adding these FIXMEs to the code in places where we need to deal with exceptions. And everything that I would like to do today would require adding more of these, and that wouldn't be great. So let's take today and deal with this instead and implement some basic exception handling. There are a bunch of different cases to handle, but I guess the first one that comes to mind is let's just write a piece of code here that throws an exception, right? And then if you call this function, actually, we can't JIT that because we don't support the throw opcode. Well, but either way, this leads to an uncaught exception, right? Because there's no try catch here, and there's also no try catch in the global scripting context where we called it. So the JS REPL tool just says like, oh, nobody caught this. But the important thing here is that this throws across the function boundary. So our JIT right now operates on per function contexts. So you JIT one function at a time. And when this happens, we essentially just need to manipulate the VM state in such a way that whoever called us can find the exception that we threw and continue taking care of it. So the code here has to continue taking care of the exception. There's also like another case where we try something and then we throw here and then we do catch it, and I guess we can set like a local variable to something. And let me actually tidy that up a little bit. So let's say we have a local here that is 1 originally, and we throw, and then the catch, it becomes 2. So if this code runs correctly, we should be able to see that the local becomes 2. Of course, that will also require implementing some more opcodes. So whatever we do here, it's actually going to require implementing some opcodes. But I guess we can start with the this case where we're just throwing across a function boundary because it should be a little bit simpler. So here is the bytecode for the JIT_me function. Extremely simple. First, load immediate constant value 1 into the accumulator and then throw the accumulator. Super straightforward, right? But how do we implement the throw opcode? I just have to look at what it does in the bytecode VM today. Okay, so it returns a throw completion, which is then handled by the run bytecode loop. Run bytecode. Right, so here is where we run all the different bytecodes. This is the a couple of the bytecodes are inline in the instruction iterator loop, but stuff like throw and other less ultra common things are here. So we set result to the result of executing the throw, and then it will be an error if we have an exception. So we store that in the exception register and then do the unwind by like jumping to the catch and stuff like that. So, you know what? Maybe I don't want to implement all of that right now. Let's do some trick instead to get a throw without having to use the throw keyword. So we have two operations implemented. We have ++i and like I less than something. So I think we can maybe do this. So like ABCD, just make a symbol. And then we try to increment the symbol because that will try to convert it to a number, which it shouldn't be able to do. And yeah, right. So then we are failing somewhere. We succeed in JITting because you can see we're printing the machine code to standard out, but we're failing in helper here on line 162 in the increment helper, where we say like, oh, this must succeed. Conversion to numeric must succeed, but of course it doesn't. It throws an exception because you gave it a symbol. Right. So what do we want to happen then? What does the code look like? The code looks like, here is JIT.me. Okay, so it's very, very simple. Get local variable 0, increment it, and then set it back to local variable 0. So I guess what we want to happen is that after we make a native call, we want to, before continuing with the next instruction, we want to check if what we just did has raised an exception, has like caused an exception, right? So I think we will do something like compile or just check exception, something like that. And then this is probably something we're going to have to do in a bunch of places, and not exactly sure what it's going to do, how it's going to work, but we'll figure it out. So check exception. And what increment currently does, if we look, let's dump out the assembly code that we're getting today. So it will make a native call to a helper. You can see here we are, this is the native call. All of this stuff is the native call to the increment helper. So first we push all the caller saved registers, then we adjust the stack for alignment, and we call cxx increment, and then readjust the stack and pop all the caller saved registers. So all of this gunk here is a native call. And I guess after the native call here, we're going to look at the, wait, what are we going to do in the native call? So the idiom that we normally use in lib.js is to return a throw completion or value, which then returns this like complicated type with a variant of either a value or a throw completion, and then it's like all kinds of stuff here going on, and I don't particularly feel like dealing with the memory layout of this template type right now. I don't want to write assembly code to deal with that. So instead, how about we just say, like, essentially what I want to do is I want to try, but try works with something like throw completion or. So if you have an error, it will return the error. In our case, let's make a new thing, like try or set exception. And then we just have to invent our own try for this, but I think that'll be okay. So we want the try to, instead of, in the case where we'd normally return the error as the throw completion, here we're just going to say like VM dot, I want to set it into a register. So bytecode interpreter reg. So we set the exception register to the error. And then we can return, I guess. Something like that. Does that make sense? Try or set exception. Okay, so it kind of, it will be idiomatically similar to what we normally do. It's just that we can't use try like we normally do in these C++ helpers, but we have to use try or set exception. Why doesn't that work? Incomplete type JSVM. Okay. I think probably I need both of those. No viable overloaded equal. Okay. Oh, because of this thing. Because release error gives you a completion, which has a value. Is that it? No? Wait, value is still not that? Oh, it's an optional maybe. Yeah. Okay. Okay, that's a bit of a mouthful, but it's okay. We don't have to write this again and again, thankfully. That's why we have the macro. So try or set exception. Okay, so what will happen now is that if this throws, then we'll set the exception register in the VM call frame, and then a return normally, and then this whatever we emit now in check exception is going to have to look at the exception register and do something nice with it. Right. So check exception needs to look at the exception register, which we get from the we'll load that into GPR 0, let's say. Sure. And then we want to I guess I need to check if it's a wait, what is that thing? The exception, all of the VM registers are JS values, so I actually have to check if it's an empty value. Empty value is not all 0 bits. Empty value is actually a specific bit pattern, so we need to test for that. So maybe I need to even like load that into a register. Operand M64, so it'll be like, no, not undefined. I want to, is encode a thing? No, that's not even a thing. Come on, dude. I want an empty value encoded. There we go. And now I can compare GPR 0 to GPR 1. And if they are equal, that means that we don't have an exception. So we'll make a label for that, like no exception. Make label, thank you. And then we'll say jump if equal. So if they're equal, there is no exception because it is the empty, it's an empty value. So no exception can then be linked at the end here. Like that. Wait, I don't have jump if equal. Jump if not equal. I see. I only made the jump if not equal. Well, this is not beautifully factored with the compare. How about we make a little thing here? I mean, essentially, I just want to take this stuff and put that here. Yes. So that I can do the same thing in my new function, jump if equal. And then we have JE instead of JNE for that, and maybe we should make a little helper for raw jump instructions. I don't know. Anyways, now we have a jump if equal, so that should be helpful. Okay, so far so good. Then what do we want to do if we have an exception though? So down here is like the no exception. And Okay, so the first thing that we're generating is like if exception is value, essentially, go to no exception, or is empty, let's say. Yeah, something like that is what we're starting with. Okay, we have an exception. Okay, so if we have one, now we need to know if we should return from the function or if we should jump to a catch. And the way that works today in the bytecode interpreter is that we have this thing called an unwind context, unwind info, but the stack of them is called unwind contexts. Okay. Anyway, so we have a stack of these objects, which have the basic block for the handler, which is the catch, and the finalizer, which is if you have a finally block, then it takes you there. And then in the bytecode interpreter loop, we just jump to the appropriate basic block. But in our case, maybe it's not that simple, because we need to actually, we're going to generate code for our handler and finalizer basic blocks. So we need to jump to the generated code for them instead. Okay, so one option would be to like manipulate the stack of these, but there are like, these are kind of basic block pointers. I don't want to mess with those from assembly code. Like I would rather just jump to the generated code directly. So let's just put this on the native stack. Right. So we'll replicate this stuff on the native stack, and then we can dedicate a register to pointing at sort of the current unwind info or whatever, or the current machine code unwind info stuff. So we have a bunch of dedicated registers, but look, like there's way more of these. We can say one is like unwind info base or something like that. R10. Okay. And then maybe we'll do like a push unwind info. Unwind info. Unwind info is such a weird name. Unwind context. I like that better. Push unwind context. Okay. So let's see. In the case where we have a function that doesn't have a try or catch or anything like that, we still want to have an unwind context, just that it's sort of an invalid one, right? So what if we just say like bool valid, and then right, so this is the intuition that he has, and maybe that makes sense, at least in the compiler, although these should probably be optional since they're not mandatory, I think. So wait, actually, now that I think about that, what the heck? We have the enter unwind context thing. This is when you do a try instruction, then you get one of these things, and it has an entry point, a label for the handler, and a label for the finalizer. Right, so we want optional label. That's what we want. All right, label, handler, and finalizer. And then we can also have like pop unwind context, and then I'm thinking when we enter the code for like an executable, then the first thing we do is set up the register array and the locals array. So maybe the next thing we should do is just push an unwind context, but an invalid one. So it doesn't need to have any handler or finalizer. And then when we check exception, then we see that, oh, the current unwind context is invalid, which means that we have to yeet the exception to the calling function. So at that point, we can just return, basically. I think that will be okay. And then we just need a corresponding pop at the end. Pop unwind context. Okay. And then what does this thing do? Push unwind context. It's going to do something. So, right. So I want to put these in the stack. Seems like the most logical place, because then I don't have to implement any kind of allocator for space. So, you have some ideas, huh? Push unwind context. So I'm just going to put these on the stack and then point the unwind context register at the base of what I just put on the stack. So assembler push, assembler operand. Wait, what is it that I want to put on the stack? So put this on the stack. I want to put is valid. And 8 bytes into that, I want to put the handler and the finalizer 16 bytes into it. But they might not be present. So, and the stack grows downwards, we should keep in mind. So if I want the finalizer to be last, I have to push it first. Oh, wait. Because they're labels, this means I'm going to have to, I don't know the final address of them yet, potentially, so I may need to patch them up later. Okay, so I think I'm going to push an M64. Here, I can actually just push like deadbeef, like this, and then patch that up. So this is like push finalizer patched later. And somebody's messaging me, but it is my little brother. So I will get back to him later. And then is valid. We can probably just do that way. Oh, and it wasn't called is valid, it's just called valid. Okay, so if we do that, then we get this on the stack. Although now we're screwing up the stack alignment because it needs to be 16 byte aligned. So here, we should just subtract from the thing. Sub. Can I sub from my stack pointer? There isn't such a thing. Okay, well, we can add that. I just want to, I thought I had a way to do that, but I guess that doesn't work. How did I implement that in assembler? Push, sub. Oh, right, I'm referencing the register directly. Okay, so I'm just gonna teach him that the stack pointer is RSP, and then we can manipulate it here. Okay, so align stack pointer. All right, and then we're gonna put the current stack pointer, unwind context base is current stack pointer. So yeah, okay. Wait, what? That's not what I wanted to do. Okay, so now, now that we've done this, the unbind context base register should point at this data structure here, essentially. Maybe this would have been a way to write it as well. Yeah. Okay. And then point unwind context base at it. Yes, exactly. Okay, so now in order to pop one of these contexts, we just need to adjust the stack pointer back, I guess. So wait, you had a bunch of ideas here, but I think in order to pop, we don't need to take the things. So we can just say massembler add stack pointer 32. So we're taking all the 4 values, these plus the padding, taking them back, and then we're also like resetting or doing the same manipulation actually to the unwind context base. It also just moves by 32 bytes. Okay, so now we've popped one unwind context. I think this will make sense. We'll see if we can actually use the data to catch an exception. But right now, since we don't have any try in the, wait, what did I call the exception? Here, there's no try and catch on finally. So we should be able to implement this by just checking the valid bit. If unwind context valid, so if it is not valid, that means return. We want to return at that point actually. So how do we check that? We load it in, and then let's see, we load it into GPR. What do I have in GPR 1 at this point? I have the exception. No, I have the exception in GPR 0, and I have the empty value in GPR 1. Now I want to look at the unwind context valid flag. So for that one, I'm just going to load it into GPR 0 and check if it is jump if equal. If it is 0, that means that we got to return. So if it's not equal to 0, that means that we have to jump to valid case. Or has exception, let's say. Handle exception. Okay. Yeah, so then we are here. But in our case, we should be here. So this is where the return goes. massembler exit to do a return. Which should then cause our caller to deal with the situation. unused parameter handler. Oh, shoot. 221. Oh, right. I need to actually patch those things up with the those addresses. So I guess if I have this is the finalizer. So if finalizer has value, then finalizer dot value dot block dot jumps to here, append assembler output size. This is going to be a little bit janky. You should probably live at another place. Wait. These are not relative though. These are absolute 64-bit. So they can't just piggyback on this thing because we need the fully final absolute 64-bit address, which we don't know until we've memory mapped the executable code. So these will be like another type of patch ups. So it's like an absolute references to here, something like that. And it's 8 bytes from here. And handler like that. Okay, so jumps to, yeah. So absolute references to here. Absolute 64-bit references to here that need patching. Yeah. Okay, and then patching up all the jumps. That can live there. And patch up all the absolute references. Can you figure out what I want? No? Okay. Now you probably can. Come on, Copilot. We were best friends. Ah, there we go. Beautiful. So the offset, block offset plus absolute reference. Wait, does that make sense? No, it shouldn't be relative at all. It should just be block offset plus the executable memory base. So we actually have to allocate the executable memory before we start doing that. Because then we can do this. So like executable memory plus block offset. There we go. Now we're going to patch those absolute references to this block. Okay, will this build? Not quite. All right, no matching member function for call to append because it's not a, oh, it's a const vector. Right. I think we hacked this elsewhere to look like this. So I'm just going to do that again here. Just a little const cast between friends. I won't tell anybody if you don't, and we'll eventually get rid of that. Okay, so that builds. What happens now if we run verification failed at assembler.h, line 306? Oh, shoot, I don't have an implementation of push M64. Operand type M64. Wait, is push M64 a thing? I'm not sure it is actually. I think you might only be able to push M32. Yeah. You can push R64. So that's what we gotta do. We gotta plop it into a 64-bit register and then push the values. Although we're just pushing deadbeef, so deadbeef can be pushed as an M32, which means we still need push im32. So let's implement that. Where was I? im32. Is that 68? Yeah, 68, push im32. Looking good. Of course, when you're pushing a 32-bit immediate to the stack, it will be extended to a 64-bit value. So you're not taking up, you're not moving the stack pointer by 4 bytes or 32 bits. You're always moving it by 8 bytes when you're in 64-bit mode, even though you're only pushing 32 bits. And actually, I remember while working on my x86 emulator that there's there's some specific thing that's supposed to happen when you're pushing a value that's smaller than the CPU machine word size. So like if you push 4 bytes in 64-bit mode, then the upper bits should be like either touched or untouched in different scenarios. I don't remember if they get zeroed or sign extended or what. There's something there, but I don't think we need to worry about that. We're just going to push some crap and it's going to get patched up anyway. The point is to move the stack pointer. Actually, now that I say that, we could just move the stack pointer instead of doing a push. But let's not overthink this too much. Okay, so can I, wait. Oh, I never changed these. Right, sorry. So these should all be im32. What's the smallest thing we can push? im8. I mean, we could also do that. I'm sure there's important information here, but let's just push 32-bit values right now. Don't have to be perfect. Okay, now we're missing something at line 248 in assembler, sorry. What is that? Compare. Oh. Wait, what was I comparing then? Jump if not equal. Jump if equal. And check exception. What did I use? What were the operands? Jump if equal. A register and a register. And then a register and an im64. Oh. It's probably one of those things where we need to pass an im32 as well, because we can't compare against an im64. Okay, now we're just segmentation faulting. So we can finally look at some generated code just to see if it looks like crap. And it does look a little bit like crap because we have dead beef here, although those are that's the invalid unwind context. So the valid bit, the handler, and the finalizer. So it's okay for those to be dead beef. So we're pushing those when entering in here, and then we're setting R10 to RSP. That's good. And then here's the big native call with the caller saved registers stuff. And then here we store the result into the VM accumulator. And then now we're going to look at the exception register, which is R8 plus hex 10. Compare it against the empty value right here. Right, so RAX becomes the exception register. RCX becomes the empty value. We do compare if they are equal. So it is the empty value. We jump to hex 93 down here. So it is the empty value, in which case we just move. Wait, what are we doing here? We're gonna ret. Oh, we're storing it into a local. Right. We're loading the VM accumulator and then storing it into local 0, which should match what I did here. Yeah, that's this operation, set local 0. So a couple of things stand out here. When we ret, we have pushed stuff on the stack. We pushed our 32 bytes of unwind context on the stack, but we we need to get rid of that, or we need to restore the stack before returning. And it would be pretty annoying to do manual unwind everywhere, so this would be a good time to maybe invent an enter and leave sequence. So let's just do that. Essentially, I'm just going to do at the start of the code sequence, we'll just do like compiler massembler.enter, and we will do a leave at the end. Leave, cool. Or actually, now that I think about this we're never going to get here because I mean, we're never going to reach the pop unwind context code here because there will always be a ret before it. There's always going to be a ret somewhere. So essentially, whenever we do an exit, we should probably just teach this guy to leave first. So we do the classic leave ret sequence. Leave is a x86 instruction, like a classic one that just restores the stack pointer. Based on the base pointer, as I recall. So there used to be a corresponding enter instruction, but I think it kind of fell out of favor, and I don't know, for whatever reason, you know, in generated code at least, I always see people manipulating setting like BSP to SP directly. Anyways, I'm getting into the weeds. Let's enter. So how would we enter? That would just be, yeah, this is essentially what we want to do. We want to push RBP and then store the stack pointer in RBP. And then that means that leave can then easily just copy back the stack pointer, the original stack pointer before we enter the function, copy that back into RSP, and we are restored as if no pushing had ever happened. Of course, we don't have to program this way. We have our fancy helpers, so we can just say like push reg RBP and mov RSP RBP, please, or RBP RSP. Sorry. Okay, that's cool. Although now that I look at that, like the stack is going to be misaligned. Don't you want to adjust that? You're not feeling it? What if I say sub? Yeah, you know what I had in mind, right? Yeah. So just to make sure that we stay 16 byte aligned, we have to do that because pushing one register out of whack with the alignment. Okay, so what would the generated code look like now? Oh, hey, look at that. We actually get an uncaught exception. That's great. That means that we have successfully set the exception register, and the calling context like discovers that, and it's like, oh, I have an exception I have to complain about. Fantastic. Let's see what the generated code looks like as well. What on earth? Oh, there's a bunch of gunk in there. Oh, because I'm doing -d. Right, I shouldn't do that. Okay. So, pushing our unwind context, the root unwind context or whatever, and then the native call for the increment, sure. And here's our exception check. And if there is an exception, we leave in red because we don't have a valid unwind context. Pretty cool. Yeah. So many zeros here. There are probably, for many of these, there are going to be like more efficient ways to encode these instructions so we can make the generated code smaller, but I'm being careful not to obsess about things like that right now because it would be such a sidetracking. Okay, so this looks pretty good for the first stage. Let's see. I think we can commit here, or wait, hold on. I want to just do the assembler changes first, I think. So factoring out compare, so we have leave, jump if equal and jump if not equal. Let's do that first. JS JIT add assembler jump if equal, and also factor out comp so we don't have to repeat it. And let's do enter and leave. Do enter and leave sequence in x86 for assembly output. This ensures that the stack pointer is restored before we return from the JITted code. Sure. And the last one was just adding M32 support in assembler push, I think. Yes. Support M32 and operands in assembler push. Okay. And then absolute references that get patched up at the end. Maybe we can that one we can do here and here. Yeah. Adds a support, add patchable absolute 64-bit or absolute references to basic blocks. Yeah. Okay. And what do we have left? Unwind context stuff. Oh, the assembler thing. Actually, I wanted that to be included in the earlier commit. Fix up, almost. That should be there, I think. Okay. And then now it's just the unwind context stuff remaining, right? I'm just gonna check that I didn't use the stack pointer thing before adding it. No, I'm good. Okay. libjs JIT propagate exceptions in the simplest case. We now establish one of those. We now establish a stack of unwind contexts similar to what the bytecode interpreter does, but here it's a stack of addresses. It's a stack of structs with addresses to the catch and finally blocks. Unwind contexts also have a valid flag, and since we the root unwind context always present pushed on JIT code entry, it has valid false, which we interpret in check exception as let our return and let our caller deal with the exception. Right. Anything that may generate an exception should now call anything in compiler that may generate an exception should now also call check exception ASAP to emit the code for handling this. And that makes me realize that I forgot to do that for we had some other native calls. We had toBoolean can't throw, but compile less than can throw. So we do that there. Maybe that would have been fine as well. We have increment and less than. Those are our two things. Both of them can throw. So now we have exception checks after both of them, and that should be good, I think. Hello. Oh, now I'm compiling and linking a bunch of other stuff for some reason. Let's just check that the very first program still JITs nicely. Okay, it JITs and runs nicely. That's good. Exception.js, the exception now ends up, we've JITted the code, as you can see, it's being printed here, beautiful. Oops, and it's an uncaught exception. Great. So let's move on to the second case, which is a bit more complicated. So we have a function that has a try with a catch, and we need to make sure that we end up in the catch. And let's see how the code is going to look like here. So we're going to have enter unwind context and leave unwind context. And then we have a throw here, and I don't want to implement throw, so let me do the thing again with the symbol. So plus plus symbol, right? Hello. Okay. So now we just have an increment there. We don't need to implement throw, but we do have to implement enter unwind context and leave unwind context, but those should map beautifully to our push and pop unwind context helpers in the compiler. So void compile enter unwind context. Thank you. And leave unwind context. Thank you again. Copilot. Where is our big switch? Right here. And maybe you want to fill that in for me. Thank you, thank you, thank you. Very nice. Okay. So compile enter unwind context. I think we might be able to just pass everything through here. No, not quite. What is the handler? Handler target, finalizer target. All right. So close. Yeah, so we're pushing a valid context now, which means that we can't just like escape to the caller of the JIT code anymore. We have to actually deal with this situation. Okay. And let me do that. And if we have those, it should actually compile now. I should be able to JIT this function, and we can. And of course we segfault because we don't know what to do. So what are we doing? And this. Actually, I guess we can take a look at like, where are we dying? Arithmetic exception. You don't say. Arithmetic exception. Oh my goodness, where are we even? We are somewhere in the middle of nowhere, I think, doing an idiv. Is there an idiv in here somehow by accident? No? Okay, we probably jumped somewhere where we don't want to be. We're pushing these here. Oh, wait, shoot, I screwed that up. We can't be pushing these as 32-bit values. Right. Yeah, because we need to have 64-bit addresses here. So where we actually patch these things up, where we're pushing the real, doing the enter unwind context, wherever that is. Where is that? There should be some push somewhere. Are we just not generating the code? No, here it is. Push keyword. Yeah, so here we're pushing some nonsense. We need to be pushing a 64-bit value, but you can't do a 64-bit immediate. So what we have to do is move it into a register before pushing it. Okay, that's my bad. Push unwind context. So this guy, it's not this simple. We can't just do this. Instead, we have to do a mov into a register and an M64. Yeah, so we do this, and then here we patch this value, just like that. We should make a helper for this, maybe, but ignoring that right now, and then we push it, right? Yeah, so that's kind of weird, but we're just going to do that twice because that allows us to push a 64-bit value. We just have to load it into a register before pushing it. A. It says 2 at the end. So wait, does this already work? How did that work? I don't know how that would work. I feel like we're never actually jumping to the catch block, are we? This might be working by accident. So local 0, that's our argument. So we have our function argument here, that's local 0. So it contains a symbol, hello. And then local 1 is this function, local, or this actual local variable, local. So we've clearly executed this thing that sets it to 2. Huh. How did we get there? Did we just like fall through somewhere? Because I'm not, not actually handling it. Let me fix this up first though. Fix up stash, rebase, and oh, they're just part of the previous commit, right? No big deal. Okay, so now that we can do that, we need to actually do something smarter in check exception. So those are fine, but we need to, in check exception, we have to emit code because, right, handle exception is the same as no exception. They just link to the same location. but handle exception actually needs to do more stuff. So what we want to do here is, what we want to do is call the catch block if there is one. So let's do that. If unwind context handler, then go to handler essentially. So we want to load, yeah, that's the second member, so 8 bytes into the unwind context. Loading that into GPR0, and then we need to test it for zeroness, or I guess, or check jump. What do I want to do? I want to compare it to 0. Compare. Yeah, compare it to 0. Oh wait, what did I set those to be? I set them to be dead beef, actually. Maybe zeros are more appropriate in this case. Okay, let's do zeros. Okay, and push or check exception. I don't want to be like testing for dead beef. Dead beef is just a placeholder, but if it, I don't want it to have any semantic meaning in the correct program. So we tested for 0, and then I think I have to compare M32, yeah. Jump. Oh, wait. I want to jump if equal. So if it's 0, I don't have a handler. So no handler. I might still have a finalizer though. So no handler is make a label, sure, and then no handler. Yeah, so this is our no handler case. Here is our handler case. So we want to, well, we want to just call it, actually. Call, or a jump to the register. Can I just jump to it? That would be nice. I guess I need to implement that function. I already have a couple of different ways to jump. What's one more? Here comes a raw jump to a register or operand. We're gonna raw jump to a reg. Don't need that. I just want this. Jump to a register. Yeah, am I getting what I want here? I wonder. I'm gonna have to look at the code that comes out to see if it's good. So got our exception checks. Yeah, jump RAX. Okay, fair enough. That's what I want. If RAX is non-zero, I want to jump to it. Cool. Okay. Jump, unwind context handler. Yeah, that's essentially what we're doing, right? Or just go to handler. We can, yeah. This is all implementing that thing. Then we have no handler. So in the no handler case, we got to check if there's a finalizer. So we do kind of the same thing. Load, yeah, that's an adder 16 into that imaginary struct we declared before. And then if it's non-zero, or if it is 0, then we have no finalizer. which I guess is the same as no exception in this case, because you had no, wait, if you don't have a, that doesn't seem like a valid thing, because then you shouldn't have an unwind context. If you have no catch and no finalizer, you would have only try. It's a little bit suspicious. No finalizer. At that point, I kind of want to trap because something is wrong. So it's like verify not reached, essentially. Yeah, doing a UD2, like a undefined opcode, like a on purpose call an invalid opcode so that we crash. Because I don't think we should have like no catch and no finally. That doesn't make any sense. No catch and no finally? We're doomed, apparently, according to Copilot. That's crash. That's an invalid state, I think. We're probably going to need to do more stuff to deal with finalizers, actually. But today we're ignoring finally. Let's ignore finally and just do catch. It's important to ignore some things sometimes so that you can make incremental progress without killing yourself. Okay, so end this. Who this? End this. I keep getting this gunk in the output. Okay, one more time. So how does our thing look now? We here is checking for the handle, for the catch. If we have a non-zero catch, we jump to, if we have zero catch, we jump to 15A. Otherwise, we jump to the catch. And here we check at the finally. If we have a zero finally, we skip to 170 and fail because we should have had one of the two. Yeah, UD2, that's our verify not reached. Otherwise, we jump to the finally. Okay, so how well does this work, I wonder? Like, what if you, let's say that we put something after this thing, local 3, does that, it becomes 3? That's cool. What if I have more stuff going on here? So I go like, try. Here I said local 3, catch. And then I trigger another exception. Local 4, local 5, and local 6. So it should be 6 at the end. And it is. That's cool. What if we don't do that? We should get 5. We do. We get 4. Okay, so it seems like we're taking all these paths. That's kind of what I wanted to verify. But we should absolutely not get here. That would be very wrong. And we don't. Although I would have expected us to see the 3 here. Wait, why don't we get the 3 though? Interesting. Local 2, 2. Do we ever get there? No, we don't. Then I guess we're not getting here either. Not quite there yet. Okay, so it's getting a little messy. Let's just tidy up a little bit so we can see what we're doing. So we're entering a new unwind Wait. What am I thinking about? Is this because I'm not resetting the... When I enter into a catch, I should clear the exception that I've thrown. I'm not doing that. I should probably do that. Let's see. So we have a handler. Go to handler. Before we go to the handler, though, we gotta like do something like exception equals, or rather accumulator exception. We got to do that first and then go to the handler. That's sort of what should happen. So before we jump to the handler, we need to load VM register. And I think we'll load it into GPR1. Thank you very much. Don't want to clobber GPR0 since I have the handler address in there. And then I want to store that into the accumulator. Yeah, exactly. So we're doing this. And then we actually also need to clear out. We need to clear out the exception so that it's empty. How do I do that? I guess I need to assembler mov. I need an empty value. So I'll put that into GPR1, value, encoded, get an empty value, and then store that into the exception register. Yeah, exactly. So this is what we're doing essentially. Just make sure that we're not like perverting the control flow with anything else. But that didn't solve my problem though. Okay, so we're clearly ending up here. And then we need to look at the bytecode. Try. So what do we have? Where are we starting? Right here. So enter unwind context here. Entry in block 7. That clearly executes because we throw and end up here. So handler, that's the catch, is basic block 2. So we're here. We're doing a leave unwind context. Setting local to 2. And then entering a new unwind context for a new try. Entry at 5. Basic block 5. So here we're setting the local variable to 3. And then incrementing local 0. But it appears that we never get to this point. So why don't we get to that point, I wonder? So if I don't do any of this, I don't want to do any of that. It still fails, right? Yeah, still becomes 2. Should be 3. We are going to have to look at the generated code. So it's going to start getting a little chunky here. Okay, so where is the thing that I want to look at? This is the first try, and the second try, I wonder if we're ever getting to 5. Oh, that's the wrong code. So I guess we're not getting to 5. Why wouldn't we get there? I gotta see the code. Oh wait, the code is here. I'm stupid. Okay. I'm just thinking like what's a marker I should be looking for? Entry 5. So the thing I'm interested in is why aren't we getting here? And that happens right after this. So right after we set local 1, right after we load immediate 2 and set local 1. Okay, so we should be able to find that. Load immediate. Here's load immediate 3. Here's load immediate 2. Okay, so load immediate 2. And then poke that into the accumulator. Poke the accumulator into local 1. Great. And then here comes our new unwind context. So we push 0 for the finalizer, or 0 for finally. Some address for the catch. This should be the address of handler here. So the address of this block ends in E7. So wait, what am I looking at here? Sub RSP byte 8, add RSP. What am I doing here? Enter unwind. This looks janky. Enter unwind context. Oh, wait. When we do an enter unwind context, we need to be jumping to the entry point. Are we doing that? No, we're just pushing it, but we also got to do a jump. Yeah, there's nothing here that says like, hey, jump to the entry point. I just skipped over that part. massembler jump to op dot handler target dot block. Totally totally missed the part where we have to actually jump to it. So it just worked by accident because they were laid out in such a way that we got the effect that we wanted, even though we didn't actually trigger the jump to the right place. So I say triumphantly, but it still doesn't work. Great. Oh, handler target I did again. It's not handler target, it's entry point. An entry point is like that. Okay. This should work. I feel it. Yes. 3. Great. Right. So we were just missing that crucial jump. So now if I do this, the latest iteration we were getting to 3, and now if I trigger an exception here, we should end up in this catch, get 4. Yes, very nice. Should get 5 after that. Great. And then 6 after that. And for finally, I'm just gonna just gonna ignore finally for now. But that is very, very nice. Okay, fantastic. So I think let me add the assembler helpers first. So let's just add them together. Libjs JIT add assembler jump operand and verify not reached. Yet another jump overload, and also a way to crash if we end up somewhere we shouldn't be while in JITted code. Okay. And then, oh shoot, wait, that's a bug fix. So let's see. There's our zeros. Oh no, that's not a bug fix. Actually, they were just changed them. So libjs JIT handle compile the enter unwind context and leave unwind context ops. These push a valid unwind context on the stack, and check exception now knows how to jump to the handler, or the catch handler if present. Finally, finalizers require some more work, but with this change, we now have basic support for try catch. That's pretty cool. That is pretty cool. That was a little bit messy, but we got it to a good point, I think. Feel good about it. And it could probably be better. And the way that this is laid out is a little bit suboptimal. I think we could do it. This could be a bit nicer if the bytecode had different metadata about exception throwing, but we're just working with the metadata that we have. So that's why we're kind of doing something similar to what the bytecode interpreter does. But perhaps a nicer piece of metadata would be that instead of maintaining a runtime stack of like the current handler and finalizer, let's say that for in each bytecode executable like this, you would sort of annotate like, oh, these instructions here, if anything in this range throws, it should go to here, to this catch handler here. And the corresponding finalizer is here. So that then you wouldn't need to maintain a stack, because every instruction would know statically where to jump without having to consult that runtime stack. That could be definitely an architectural improvement here. But since we don't have that information from our bytecode generator at the moment, and it's not in the executable, then I can't know statically where to go. So I'm just going to ignore that for now and leave it as a nice refactoring for our future selves someday, but not right now, since I just got this working. Okay, that's pretty sweet. I think that definitely makes me feel better about exceptions. Oh shoot, I didn't actually update this one, so I guess we should do that as well. Less than, and allow it to throw. No, not try or throw. Try or set exception. Cool. That's pretty sweet. Less than, does that also fail? I think that probably also fails for symbols. Like throwing symbols at anything is usually a pretty easy way to screw everything up. Let me see if that works. Let's say like 0 less than s. Symbol, hi. Cannot convert symbol to number. Cool. That is very cool. So that now works. And if I didn't make this change, it should have failed, right? Let's just verify that I'm looking at the right thing. Yes, that it would have failed there. Verification failed. So now this is all we need to do to support exceptions in our little native bridge code helper things. Fantastic. Look at him go. Handle exceptions in less than. Cool. All right. that was a little bit of a journey, but we got there in the end. So I'm very happy with that. If you made it this far, thank you so much for watching, for hanging out. I hope that you saw something interesting here today. I'm definitely happy with the way we're coming along, although I'm sure we're going to have to change all kinds of things about this JIT compiler as we continue building it. But even so, I think this is this kind of thing that you just have to start doing in order to find the pain points and the architectural peculiarities and requirements and so on. So I'm really glad that we're on track. We're on the path. So yeah, thanks for hanging out. See you all next time. Bye.